120, 180, 255.
Hello and welcome to one more home labs tutorial on the Arduino Uno. In this tutorial, we'll be using a tactile switch to trigger pin change interrupts on the Arduino Uno. This would in turn cause the Arduino Uno to ramp up the speed of a DC motor through a range of preset values. The speed setting of the DC motor would also be displayed on a serial monitor. So here's our setup. We have a 5 volt power supply and this goes to the MB102 breadboard power supply. Here's a tactile switch. One end of the tactile switch is connected to ground and the other end is connected to pin 8 of the Arduino Uno. Then we have the LM293D motor driver IC. The enable pin of the motor driver IC is connected to pin 11 of the Arduino Uno. We are using only the left side of the LM293D in this tutorial. These two pins are grounded. The direction pins input 1 and input 2 are arbitrarily connected to 5 volts and to ground. You can of course reverse these connections, only the direction of the motor would reverse. Then the motor itself is connected to out 1 and out 2 of the LM293D. Here's a connection through this red wire. This is coming from a 9 volt power supply which is being supplied to the LM293D's VCC2. The ground terminal from the 9 volts power supply is connected to the ground terminal of the MB102 power supply. This ensures that the entire circuit has a common ground. The Arduino Uno's ground pin is also connected to the MB102 ground rail. Thus, the entire circuit shares a common ground and this ensures that we wouldn't have any errors in our experiment. So now I am going to press the tactile switch. I press it once, the run status gets updated to on and the speed is 120. I press it again, the speed is now 180 and the run status remains on. I press it twice this time and so the run status goes to 255 and then to 0, that is off. We go through this cycle once again. 120, 180, 255 and then 0. Let's do this again. 120, 180, 255 and 0. So let's now have a look at the code. We have AVR interrupt.h since we are going to use pin change interrupts. The motor pin is pin 11. We have pin 8 where we are going to watch for pin change interrupts. This Boolean variable run, so this is basically going to indicate the state of the motor, whether it's running or it's paused. So false would basically indicate that the motor is stationary. We have a variable Boolean which basically enables us to distinguish between the high to low and the low to high transitions. Please note that the Arduino Uno by itself cannot distinguish between these two state changes in a pin change interrupt. We have this integer called speed which is going to track the speed of the motor. We have an integer called step, so this is going to help us to move through this array, and this array happens to be a list of speeds which we are going to cycle through. We can also have a longer array, but for the sake of the demonstration I use a small array consisting of 3 elements. Then these variables, these are basically for printing it out on the serial monitor, and in a later variation we will be printing out these values on the LCD, and these help to make the experiment more interactive. So here's our setup loop. Since we're going to print out the speed onto the serial monitor, we have serial.begin 9600. We clear all interrupts, set the pin mode of the motor pin, that is pin 11, to output. we set the pin change interrupt, we hold it to high using this internal pull-up resistor. This code here, this is basically enabling the pin change interrupts on pin 8, and this is basically setting the number of steps. So we take the size of speed list, that is the array which contains the list of speeds. We divide it by the size of the first element, and this basically gives us the number of elements in the array. And this enables us to set up a loop which can cycle through the elements of this array. Then we have the void loop itself. So if run happens to be false, then we digital write the value of run to motor pin, that is we stop the motor. In all other occasions, we analog write the speed to motor pin, so the motor starts rotating at a particular speed. And then this variable allo, if this is set to false, this means that the interrupts are disabled. So what this means is that we have gone from high to low, the interrupts been triggered, and now we have temporarily turned off the interrupt. So this means that we now have time to interact with the user, and we can type out all these things. And once we're done with typing this information on the serial monitor, then we reset allo to true to tell the Arduino that now it can be ready for watching further changes on the pin change interrupt. So here's the interrupt service routine. So this, we are basically reading the value of pin 8, and if pin 8 happens to be 0, that is it's a high to low transition, then it means that we'll be firing the interrupt. And of course allo has to be true. Allo is a flag which tells us that we're going from high to low. So here are the three conditions. The first condition is that step happens to be 0. Second condition is that step happens to be less than the number of steps, however it's not 0. And the third situation is that we have crossed the number of elements in the speed list array, and so we need to get back to the original situation. We look at these three conditions in a little bit more detail. So if step happens to be 0, then what we do is we toggle run and set the speed to speed list of step, that is speed is set to 0, and we increment the step so that we are ready for the next cycle. On the other hand, if step happens to be greater than 0 but less than the step size, then the step is incremented and the value of speed is read from the speed list. And if we look at this, then this speed is getting written to the motor pin using this analog write. And finally, if we have exceeded the number of elements in the speed list, in this case there are 3 elements, then step gets set to 0, so we are back to square one. The run position goes from run, that is it is going to go from true to false, and the speed gets set to 0. And this is basically turning off the interrupts temporarily. This is where the interrupts are paused, and this is where the interrupts are allowed again. So this makes sure that only one transition is picked up, and this transition is not picked up when you release the switch, and the code works exactly as we want. So now we have a look at the video yet again.
120, 180, 255.
And that's it for this video. Thank you for watching, and if you like our content, then please do subscribe to our channel and like the videos. Thank you.